Imagine stepping outside your home. You walk forward, turn left, and climb a set of stairs. Simple, right? We navigate our three-dimensional world effortlessly. But what if I told you there might be another dimension hidden from our perception? A fourth dimension, where reality as we know it bends and twists in unimaginable ways. Could such a place exist? And if so, what secrets might it hold? To grasp the concept of a fourth dimension, we must first understand the dimensions we experience every day. Imagine a single line. This line represents one dimension, possessing only length. It is the simplest form of measurement, a mere extension in one direction. Now add another line perpendicular to the first, creating a flat square. This square now has both length and width. This is two dimensions, length and width. It is a plane, a flat surface that extends in two directions. To achieve three dimensions, we simply add another line perpendicular to the other two, forming a cube with length, width, and height. This is the space we live in. This is the world we perceive, a world of three spatial dimensions. Everything around us, from the smallest objects to the vast expanse of the universe, exists within these three dimensions. But what about a fourth dimension? How do we even begin to conceptualize it? Just as we added a line to move from two dimensions to three dimensions, we can theoretically add another perpendicular line to enter the realm of four dimensions. This new line, however, is not something we can easily visualize. This fourth line represents a direction we can't visualize, a direction beyond our spatial comprehension. It is an abstract concept, one that challenges the very limits of our understanding. This is where the human mind struggles, for we are not equipped to perceive a reality beyond our own. Our brains are wired to understand three dimensions, and the idea of a fourth dimension is something that exists only in the realm of mathematics and theoretical physics. Mathematicians and physicists use complex equations and models to describe the fourth dimension. These models help us understand how a fourth dimension might interact with the three dimensions we know. One of the most famous representations of a fourth-dimensional object is the Tesseract, a four-dimensional analog of the cube. While we can create 3D projections of a tesseract, truly understanding its structure requires thinking beyond our three-dimensional experience. Exploring the fourth dimension pushes the boundaries of our imagination and challenges us to think in new ways. It opens up possibilities for understanding the universe in ways we never thought possible. As we continue to explore the mysteries of the universe, the concept of higher dimensions remains a tantalizing frontier. It reminds us that there is still so much we have yet to discover and understand. From lines to worlds, our journey through dimensions is a testament to the power of human curiosity and the endless quest for knowledge. Often we hear time referred to as the fourth dimension, but what does that really mean? How does time fit into our understanding of the universe? While time shares similarities with spatial dimensions, it is fundamentally different. Spatial dimensions allow us to move in various directions: left, right, up, down. Time, however, is a different beast altogether. We can move back and forth along a line, but we experience time as a relentless forward march. No matter what we do, we are always moving forward in time, never backward. However, thinking of time as a dimension can help us begin to conceptualize higher dimensions. Just as we can imagine moving through space, we can also imagine moving through time, even if we can't actually do it. Imagine a film reel of your life. Each frame of the reel captures a single moment, a snapshot of your existence. Each frame represents a moment in time, a snapshot of your existence in three dimensions. These frames, when played in sequence, create the movie of your life. The film reel, with all its frames, represents your life unfolding through time, a four-dimensional perspective. This perspective allows us to see how our lives progress, how we change, and how we grow. In this way, time acts as a dimension that allows us to track change and movement within our three-dimensional world. It gives us a way to measure the passage of events, to understand the sequence of occurrences, and to grasp the concept of cause and effect. By thinking of time as a dimension, we can better understand the fabric of our universe. It opens up possibilities for exploring concepts like time travel, the nature of reality, and the potential for other dimensions beyond our perception. So, the next time you look at a clock or watch the sunset, remember that you're not just observing the passage of time. You're experiencing the fourth dimension, a fundamental aspect of our existence that shapes everything we do. While we can't directly experience the fourth dimension, we can use analogies to catch fleeting glimpses of its potential. Imagine a flat, two-dimensional being living on a sheet of paper. Their world consists only of length and width. They cannot perceive height. If we were to pass a three-dimensional object, like a sphere, through their plane, they would only see a series of changing two-dimensional shapes. This is analogous to how a four-dimensional object might appear to us. We might perceive only fragments, sections of the object as it intersects with our three-dimensional reality. These glimpses would appear as strange, shifting shapes, defying our understanding of physics and geometry. One of the most intriguing concepts in four-dimensional geometry is the tesseract, also known as a hypercube. This geometric marvel extends the idea of a cube into the fourth dimension, creating a shape that is both fascinating and complex. To understand a tesseract, let's start with its three-dimensional counterpart, the cube. A cube is a familiar shape to most of us, a solid object with 6 faces, all of which are squares. A cube is made up of 6 squares connected at their edges. Each square face meets another at a right angle, forming the familiar box-like structure we all recognize. A tesseract, however, is comprised of 8 cubes, connected in a similar fashion. Imagine each face of a cube being another cube, extending into a dimension we can't directly perceive. Visualizing a tesseract in its entirety is nearly impossible for us. Our three-dimensional minds struggle to comprehend the full nature of a four-dimensional object. We can, however, try to grasp its form by unfolding it. This process helps us break down the complex structure into more familiar, three-dimensional components. Just as a cube can be unfolded into 6 squares, a tesseract can be unfolded into 8 interconnected cubes. This unfolding process reveals the hidden connections and relationships between the cubes that make up the tesseract. This unfolded shape, while still challenging to visualize, gives us a hint of the tesseract's intricate structure and the complex relationships between its parts. By studying the unfolded tesseract, we can begin to appreciate the beauty and complexity of higher dimensional geometry and the ways in which it extends beyond our everyday experience. The Tesseract serves as a gateway to understanding the fascinating world of higher dimensions, inviting us to explore the limits of our imagination and the boundaries of mathematical possibility. The concept of higher dimensions isn't limited to thought experiments and mathematical curiosities. In fact, it plays a crucial role in our understanding of the universe. Einstein's theory of general relativity, for example, describes gravity as a curvature in the fabric of space-time, a four-dimensional entity combining space and time. Furthermore, string theory, a leading candidate for a theory of everything, proposes that the universe exists in 10 dimensions, 9 spatial dimensions, and 1 time dimension. These extra dimensions, according to string theory, are curled up and hidden from our perception, yet they hold the key to understanding the fundamental nature of reality itself. The implications of understanding and potentially harnessing the fourth dimension are staggering. Imagine manipulating space and time, traversing vast distances instantly, or even altering the very fabric of objects. While these concepts seem like science fiction, they are grounded in the theoretical possibilities presented by higher dimensional physics. Perhaps one day, far in the future, we will develop technologies that allow us to perceive or even interact with these hidden dimensions. Such advancements could revolutionize our understanding of the universe and open up possibilities beyond our wildest imaginations. While the fourth dimension remains elusive, our quest to understand it speaks to a fundamental human drive, the pursuit of knowledge and the exploration of the unknown. The universe is full of mysteries, and each discovery, each step forward in our understanding, brings us closer to unraveling the grand tapestry of reality. The fourth dimension is a reminder that our perception of the universe is limited, that there may be realms beyond our comprehension waiting to be explored. This realization shouldn't be a source of fear, but rather an invitation to embrace the wonders that lie beyond the boundaries of our current understanding. The concept of the fourth dimension, while challenging, is ultimately a source of wonder and inspiration. It reminds us that the universe is far more complex and mysterious than we can imagine, filled with unseen dimensions and hidden possibilities. As we continue to explore the cosmos and delve deeper into the laws of physics, who knows what other secrets we might uncover, what other dimensions we might find hidden within the fabric of reality. The journey of discovery is far from over,